Iberê, is it possible to see from Earth using a telescope the United States flag that was planted on the moon? But that's a really good question, and the answer is even better. I'm sure you'll be surprised. So stick around until the end, because, as is tradition, I'll leave this one for last, all right? Hey, Iberê, is that unicorn story true? Look, it's true, but hold on. An animal like a unicorn really did exist, but it didn't fly, it didn't have colorful manes, it didn't have superpowers, and it wasn't a horse either. It was more like a rhinoceros, and it's an animal that went extinct about 38,000 years ago. The name was Siberian unicorn, or large-horned rhinoceros. The scientific name is Elasmotherium sibiricum, because it lived there in Siberia. Looking at the artistic depictions of this animal, it was basically a big rhinoceros with just one horn. Because if you look at today's rhinoceroses, they have two horns. They're not unicorns, they're
Bicorns?
bicorns? Cow? Moose? I mean, what do we call it? The truth is they've never found a full skeleton of this animal, but they did find some bones and did some DNA analysis. From these bones, we can tell that the animal was about 2 meters tall and 6 meters long, weighing around 4 tons. It was much bigger than the rhinos we have today, a gigantic creature. And what I think is coolest about all this is that humans lived with this animal 38,000 years ago. There were already humans around back then. Maybe someone even ate unicorn meat. By the way, there's a really cool video I want to make about the megafauna that existed at that time and went extinct during the Ice Age, because there were many large animals, such as the mammoth. That disappeared, and it wasn't that long ago. Animals that lived with humans, but went extinct before photography or any other kind of record existed. Cool video idea, right? But if you want to know about the real unicorn that still exists today, what I think is really cool is the narwhal. It's a kind of whale that lives up near the North Pole, around Greenland. And it has a big horn that's very similar to the unicorn horn people draw. That's spiral-shaped. Actually, it's a modified tooth, but when you look at it, it really looks like a horn. It's a really cute animal, and there aren't many photos of it because it lives in a very remote place. It's not an animal we get to see very often. It's worth looking up narwhal, okay? Look, the next question was asked by Marina, but Daniel, who works with us here, also wanted me to include it and answer it. Why is dry wine liquid? This has nothing to do with the physical state of the wine. Dry wine isn't powdered wine. We call it dry wine because it causes a dry sensation in your mouth. It's wine that has very little sugar. Usually, this dry feeling comes from a substance in the wine called tannin, which is the same substance that causes astringency in persimmons. When you eat a green persimmon thinking it's sweet, that bad feeling in your mouth, like your mouth dried up inside, that's the tannin. It's the same thing that happens in wine. That's why the opposite of dry wine isn't wet wine. It's sweet wine, wine that has a lot of sugar. And there are a lot of people who don't drink much wine who prefer sweet wine over dry wine because it tastes more like juice. And there are also a lot of people who really like wine and hate sweet wine, because usually these sweet wines have added cane sugar. So the extra sugar there, it's not that it came from the grape or anything, it's sugar that was added artificially. Some people who love wine think this ruins it and say it's not even wine anymore. I won't debate that, but I prefer wine without added sugar. In your opinion, with everything you know and follow about current technologies, do you think it's really possible for humans to inhabit Mars? It's possible, yes, but it's not easy at all, huh? What's the big problem? If you send humans to Mars, it's very hard to come back or do any maintenance, to send rockets there, because Mars and Earth are in a kind of dance around each other. Sometimes Mars is really far away, and at those times, you can't send rockets. So Mars gets closer to Earth about every 2 years or so, which is your chance to send a rocket. So if you send a rocket now, you'll only be able to send another one in about 2 years. So people would need to survive there for around 2 years without rockets delivering supplies like water or food, unlike the International Space Station, right? So the astronauts who live in space today are very close to Earth, only 400 kilometers away. Sending rockets is easy. They arrive the same day and transport supplies back and forth. Mars is very different. For example, you'll need to recycle your own water. You'll have to grow plants there to get food or bring a huge stock of food. If any medical problem happens, you have to solve it right there at that moment. And I've already told you that communication from Mars to here is very slow, because even though radio waves travel at the speed of light, Mars is so far away that sometimes it would take 40 minutes for a message to arrive. If there's a medical emergency, it's really complicated. And another really complicated thing is creating some kind of rocket that can leave Mars and return to Earth. What does that mean? What's the problem with that? that the people who go will probably go with the expectation of not coming back. Whoever goes on those first trips probably doesn't know if they'll ever return to planet Earth in their lifetime. Heavy, right? But there's something I'm really curious about. Here's a tip for anyone who's a billionaire, okay? Try the following experiment. Create a dome underwater in the ocean and have some people live there. And then, in this dome, you won't have any contact with the outside environment. You really have to live inside. It could even be a submarine. And then you'll have to plant, you'll have to recycle your own air, and live sustainably within that little space, without any outside help. How long do you think it would last, huh? It's not easy at all. And Iberê, if there's a balanced feed with all the vitamins and minerals for animals, why doesn't it exist for humans? It would be easy to measure the daily amount, especially for diabetics. I've heard of a sea ration, but never seen it sold. Good grief. Actually, there are several meal replacement projects, but none of them catch on. You can't buy meal replacements at the supermarket. It's not easy to find that stuff. Do you know why? Because we don't like to eat that kind of thing. Eating is one of the coolest things we do in our lives. Eating is very pleasurable, we like it, everyone really enjoys eating. So, you can notice that the big events in our lives have a lot to do with food. For example, when you're going to introduce your boyfriend or girlfriend to your parents, where is this introduction going to happen? How are you going to do it? It's going to be at a dinner. If you're going to propose to someone, how do you do it? At a dinner. If you miss seeing your grandparents because they live far away, what do you plan with them? Lunch. You haven't seen your group of school friends in a long time, and you want to give everyone a hug. What are you going to do? Barbecue. You're going to get married, you have that beautiful ceremony and all that. What happens afterwards? Everybody eats. You manage to save some money to travel, that's great, you're going abroad. What's the first thing you do when you get there? You try new food. I mean, eating isn't just to fill your belly. It's not just for us to survive. We eat because we like it. It's really good to eat different things, different flavors, to try different textures. We've already made a video here on Manual de Mundo showing that even the sound food makes when you bite it makes a difference. So, are you really going to want just a food ration? Even the act of cooking is special. Cooking is often an act of affection you're doing for someone else. It's care you have for another person. Someone who cooks well is highly valued. Someone who makes good barbecue, someone who makes decent pasta, a person who can do something cool in the kitchen is valued by the group. Do you really want to lose that? You might say, hey, Iberê, but there are emergencies, right? For example, I don't know, a soldier on a battlefield. He might need to eat something really quickly there. In some way that meets all his needs really fast. Man, he's already in a terrible situation, and you still want to give him bad food? The only good thing this person will have that day is some halfway decent food he can eat there. So let's create some kind of food that's tasty, not just human chow, right? In short, you can make human chow, it's not hard, but people don't want to eat chow, right? One of the best questions I have here today. Hi, my name is Bernardo, and I'm 8 years old. My mom tells me to take a shower every day, but I don't understand why. Why do I have to take a shower every day, even on days when I don't leave the house? Bernardo, but this is a problem that affects pretty much all 8-year-old kids. So this answer isn't just for Bernardo, okay? It's also for all the parents of 8-year-old kids like Maria Alice's dad, Enzo's, Valentina's, Enrico's, Gael's, Luna's, Luca's, and Barbara's. Bernardo, let's think about the dirt that builds up on your skin during the day you stayed at home, okay? You didn't leave the house and spent the whole day watching TV, which is something that shouldn't happen, but sometimes it does, right? First, the main thing you should wash off in the shower is poop. You likely used the bathroom, did number 2, and wiped with toilet paper. Does toilet paper really clean everything properly? To think about whether it does or not, let's imagine you're walking barefoot on the street. Then you step on some dog poop, that really sticky kind that was just left there. How would you want to clean that? Would you just use toilet paper to clean that off and be fine? No, you'd use water and soap, right? It's the same. You only wiped with paper after using the bathroom. You need to handle that later, right? But Iberê, I wash my butt after using the bathroom. Wait, I don't need to know where you wash. I'm talking to Bernardo. Also, your body always releases sweat, and sweat isn't just water. Sweat is water with salt, and salt is something that absorbs water. So the humidity in the air will keep gathering where there's already salt on your skin. It's tough to dry an area that's been sweaty, since your body also releases oil. If you touch your forehead and then glass, you'll see oil. This also happens on your scalp, so your hair gets oily and dirty. Plus, there's dust from your home. Have you noticed dust builds up on your furniture, so you occasionally need to wipe or dust it? On you, pollution and dust will also accumulate and stick to the oil and sweat that's already there. What's more, our body keeps shedding dead cells. Cells are like the building blocks that make up our whole body, right? Our skin keeps renewing itself, and releases tiny little pieces of dead skin. So if you don't wash yourself, your skin will be completely covered with bits of dead skin. Do you know who likes to eat that? Fungi and bacteria. That means if you don't wash yourself, you'll get smelly feet. You'll get athlete's foot, because these organisms are there in the moisture, eating those leftovers from you. In short, even on a day when you stayed inside all day without exercising, you'll still be pretty dirty. It's worth taking a shower. Deal? And if you're a father, don't forget to share this video with other fathers, because I'm sure it will be very useful. There is real danger when it comes to space debris in Earth's orbit. To start with, you'll understand what this so-called space debris is. Is it the poop that astronauts release up there? It's not. The problem is that we've already launched a lot of rockets, a lot of satellites, right? These are the objects that keep orbiting around the Earth, and a lot of those rockets left pieces up there. Many of those satellites broke down. They're up there not working anymore, already dead, and they keep wandering through space around the Earth, okay? They don't go away, they stay in orbit, just like the International Space Station. We track these objects from Earth, and many people study their locations, but there are a lot of tiny little pieces, so it's nuts, bolts, little bits of who knows what, and that's practically invisible. Okay, but what's the danger of all this? Falling to Earth isn't a problem. When these things enter the Earth's atmosphere, they come in at such high speed that everything catches fire and breaks apart. No one has ever died because of space debris falling on their head, nor has anyone died from a meteor either, which is another thing that falls all the time. The problem is that these objects are moving at extremely high speeds, like 20,000 or 30,000 kilometers per hour. Just so you have an idea, a .38 caliber bullet, it travels at about 1,000 kilometers per hour. That's 30 times faster than that little space debris screw spinning up there. Imagine if that hits a satellite, or worse, if it hits a space station where people are living inside. So the worst that can happen is harming those astronauts up there. They could even die in an accident like that. And another thing that can happen is a satellite colliding with another, sending pieces flying everywhere. Then those pieces hit more satellites, quickly creating a huge mess up there. And then you can't send other satellites. You can't launch other rockets up there. And then we're in trouble, because our GPS system, satellite internet system, telecommunications, and everything else, which we depend on satellites for, will be affected. Not to mention all our research, domestic travel, international travel, right? Interplanetary travel would only go to Mars. But to the moon, how do I even talk about travel? Space travel, would be affected. And Iberê, do you think there will be cars, buses, etc., powered by sunlight? First of all, we have to be careful with this idea of being powered by sunlight. Are you imagining something like you go out in the sun and the car moves just with the light that's hitting it at that moment, without a battery? I think it's very, very difficult, because there isn't much sunlight hitting the car's surface. It's not enough to make the car move, unless it's an extremely light car. Nothing like the cars we see on the street today. So, a car like the ones we see on the street today, running only on the sunlight that's hitting it, it's practically impossible, but you can, yes, have cars, buses, etc., that have solar panels on top, which receive sunlight when they're parked. And then, when you start the car, you can drive a little with that car, using the energy that was stored there. That would work, but even so, the area is small. You wouldn't be able to store that much energy. If it's a car that you use very little, like, I don't know, your work is 5 kilometers from your house, and you only use it to go to and from work, you'd probably be able to go to work and come back without putting fuel in the car, without ever plugging it in, which would already be pretty cool, right? But I still think the solution isn't to put the solar panel on top of the car. The solution is to put the solar panel on top of houses, on garages, because then you can have panels that move, that follow the movement of the sun. And then you're going to generate much more energy than a panel that's stuck on top of the car and is really expensive to install, right? To attach a panel onto the car's bodywork and all that. There are some electric cars that have done this. It would be cheaper and more efficient to place it on the garage roof and connect it to the car, or store it in a home battery first. By the way, what are Saturn's rings made of? That's really cool. Saturn's rings are made of ice and rock, and they're very, very thin, extremely thin. They're about 10 meters tall, and the craziest thing is that there are several rings. There are mainly 7 of them, and they rotate at different speeds around Saturn. So it's kind of like you have giant highways around Saturn, spinning at different speeds. It's a pretty crazy thing. We don't know exactly how they were formed, but the hypotheses are that one moon collided with another and ended up staying in orbit around Saturn. Or a comet or asteroid created the dust that we see from afar. It's very beautiful. The first person to see these rings was Galileo in 1610. And it's really cool because he couldn't see very well. It looked like a planet with ears. And he even used the word ears to describe what he was seeing there. And another interesting thing is that it's not just Saturn that has rings, okay? Jupiter, Uranus, and Neptune also have rings, but they're not as visible. They're not as elegant as Saturn's rings. Felipe, who's behind the camera filming, just asked a really good question. He asked if space debris couldn't form a ring around planet Earth. It could, but the thing is that the debris isn't necessarily all orbiting in the same plane, like a disk. Many objects orbit differently. Even the International Space Station has various orbits around Earth. Not all orbits are along the equator. And Iberê, when a fat person loses weight, do they lose atoms to the environment? That's a really, really cool question, huh? Let's start with logic. If I used to weigh 85 kilos, and now I weigh 80, I lost 5 kilos somewhere, right? So everything I have here is made of atoms. These atoms left somehow. The question is, how did they leave? A lot of people might think the answer is obvious. How do we lose mass? Yeah, it's in that conversation we had with Bernardo a little while ago. No, actually it's not. When we lose weight, we mainly lose atoms. Do you know how? Through the mouth and nose, by breathing. What's happening? The fat in your body is basically made up of carbon, hydrogen, and oxygen. Your body uses that fat to get energy from it. But to get energy, you need to make that fat react with oxygen. That oxygen you breathe in. So, you breathe in so you can make that oxygen react with other things inside you and generate energy. What does this chemical reaction produce? It creates carbon dioxide, which you exhale when you breathe. Water, which we also eliminate through breathing. When you breathe, you release a lot of water, but you also eliminate it through urine, feces, sweat, and so on. And you also get energy, which is what we need to survive. So, in the end, when we lose weight, we're releasing carbon dioxide, water, and using the energy that was stored in that fat. That carbon dioxide will leave almost entirely through breathing, and a good part of the water as well. If you didn't know that, I think now's the time not to forget to give a thumbs up, right? If you've made it this far in the video, you're probably wondering about this background behind me, which is new and has never appeared in any video before. This used to be a room that we completely remodeled to make our podcast studio, which will be called Na Trilha dos Gigantes, and we're going to launch it very soon. The idea of this podcast is to interview people who are really, really good at what they do, so they can explain how they got there, what difficulties they faced in the beginning, and that way we can learn from them too. After all, here at Manual do Mundo, the idea is to learn, and always keep learning. At the moment I'm recording this for you, we've already done 9 interviews. Some of the people we've interviewed: Ana Paula Padrão, Amir Klink, Drauzio Varela, Daniel Rezende, the director of Turma de Mônica, Rita Lobo, and many others. We've interviewed some amazing people doing wonderful things. I'm reviewing the video edits, and they're turning out really good. Each interview will be a little over an hour long. We don't want to make a tiring podcast. We closely studied these people's lives to ask meaningful questions and avoid random, aimless conversations. I'm excited and will soon release a short video explaining why we created this podcast in more detail. I think you'll really like it. I enjoyed doing it. It was very different from anything I've done before, and I'm happy. Iberê, I've always wondered, what's the difference between yogurt and dairy drinks? I've had that question too. You go to the supermarket, and there's a container that looks almost exactly like a yogurt container, but it says dairy drink, and on yogurt it doesn't say dairy drink. What's the difference? Yogurt is milk that has been fermented by bacteria, so the consistency of the milk changes a little, it gets thicker. You can add some fruit to give it flavor, and that's yogurt. The dairy drink is milk with added whey, and whey is the liquid that's left over mainly when you make cheese. It's the leftover from cheese production, which still has a lot of nutrients and can be used. The dairy drink isn't necessarily worse than yogurt, okay? It will have fewer nutrients, but you can add things to the dairy drink. You can add protein to make it richer, vitamins, and so on. But the problem is when you drink something thinking it's something else, right? Dairy drink is not milk. It theoretically has fewer nutrients than milk. You have to take a look at the box, read it carefully to see if it's really worth drinking, okay? Mind Soul Manual, spell checker, right? Can lightning turn sand into glass? I saw it in a scene from a series on TikTok. Yeah, you see all kinds of things in those short videos, let me tell you. But yes, it can happen. When lightning strikes, if you have the right kind of sand underneath, at the right temperature, with the right humidity, it's not always going to happen, okay? But it can happen. The lightning can heat the sand so much that it melts and forms glass. And what's even more interesting is that the shape the sand takes isn't like a puddle of glass. It's like the branch of a tree underground. Because the lightning spreads out, it melts everything, and it turns into something really wild. It forms a type of rock that even has a name. It's called fulgurite. But if you're imagining a glass branch that's completely transparent and pretty, like something made in a factory, that's not what happens. Imagine glass that has just been melted and is covered with sand around it. The sand around it sticks to the glass like breaded steak. What's more, these objects are extremely fragile because they're usually hollow. And also, it's not an object that comes out of the sand. It stays buried there. So, these objects, they're only discovered when the wind blows the sand away or if someone digs around. And it's very likely that they'll break in the process. So, if you search for fulgurites on Google, you'll find a bunch of broken branches coated in sand, which are really beautiful, really interesting, but it's not exactly what we imagine. But now let's go to the final question, the big question. The best question, in fact, every time Temer answers, I launch a poll to find out which question people most want answered, and this one won. After all, if we point a telescope at the moon, will we be able to see the flag that was planted there by the astronauts? First of all, let's understand the story behind the flag. Whenever we went to the moon, they landed with a small spacecraft like this, okay? It's not aerodynamic because there's no air on the moon. So you don't need it to be able to cut through the air. There's no problem, it looks all weird. They land on the moon and then do a bunch of things there. The main thing is to collect samples from the moon, to bring back to Earth, to do a series of studies and so on. And symbolically, every time they went, the guys planted a flag, stuck a flag in the ground. One important thing for you to know about this flag is that it's not loose, okay? It's not loose fabric. There's a pole that stands vertically and another one horizontally, which is to keep the fabric stretched out so it looks good in the photo. Otherwise, it would be a flag all droopy, like the ones we have here on Earth. It only stays stretched when the wind blows. And on the moon, there's no wind in this case. So, the flag would never look nice. There had to be a rod on top to make it look good. When they leave the moon, the spacecraft splits into two. The bottom part of it serves as a launch base and only the top part takes off, so this part takes off and they leave this part on the moon. So, it's not just the flag that's there. There's also half of the spacecraft that stayed. An interesting story that Buzz Aldrin told. Buzz Aldrin is one of the astronauts who first set foot on the moon, okay? The first was Neil Armstrong, but right after, Buzz Aldrin was with him and stepped there too. He said when they took off, the rocket's jets hit the flag, so the first flag planted is likely gone. It was destroyed. But since 6 missions reached the moon, the other 5 flags remain. I mean, are they really still there? Look, if you point a telescope at the moon, even the best telescope we have here, you won't be able to see anything, not the flag nor the rest of the spacecraft. But hold on. We've already found these objects, and it was with a telescope. But not a telescope here on Earth. There's a NASA mission that sent a robot that stays in orbit around the moon. It's the Lunar Reconnaissance Orbiter. Let me see how to say that in English, because honestly, I don't know how it's said. Lunar Reconnaissance Orbiter. Lunar, what does that mean? Lunar Reconnaissance Orbiter. Just like in Portuguese, it's hard to understand, right? It's an object that orbits the moon. It has a series of instruments to survey and study the moon. Among them, a microscope, a telescope, a super camera that keeps taking pictures of the moon, and that spotted those abandoned lunar mission remains. In these photos, you can clearly see the remains of the spacecraft that were left behind. You can see the astronauts' footprints, and you can see where the flag was left. Of course, the flag we see is just a little shadow that's there, right? It's like a rock. But if you look exactly where the flag was planted in relation to the spacecraft on that mission, you can see that yes, that thing casting a shadow next to the spacecraft is exactly the flag that was placed there. And that's how we can prove, how we can know that man really did land on the moon and did everything they said they did. Because the marks, the footprints, everything is right there. To this day. Can we agree? It's really cool, isn't it? So our podcast will be released soon. The highlights will be published on our highlights channel. So if you're not subscribed there yet, please subscribe. Also, because we'd really like to get that 100,000 subscribers plaque, which is so cool. And a lot of people are also asking me when we're going to release our big chemistry book from Manuel do Mundo. We're finishing up the review of this book, and we'll be holding the launch event soon, okay? And I've already promised you that at the São Paulo launch, I'll bring the Submarino Cortado so you can go inside it. That's a promise I have to keep. The only thing I can't guarantee 100% for you is the date of this launch. because we're reviewing the book with a lot of care, very carefully, so that the book turns out really good for you, okay? So it'll probably be at the end of the year, November, beginning of December, but it will come out, all right? Big hug.